Hi, welcome to a session on trigonometry, and we're going to focus on trig identities in this video. So we are given the question that comes out from the NSC November 22 final paper, and the question starts off with, given the identity cos x plus y times cos of x minus y is equal to 1 minus sine squared x minus sine squared y. And the question in the first one is to prove the identity. Now, to prove the identity, we either start with the left-hand side or the right-hand side. And I'm going to choose to start with the left-hand side. And the left-hand side says cos of x plus y times cos of x minus y. Now, I'm going to use the compound formula to expand. So the first one would be cos plus will change to minus sine. And the angles involved is x, y. So there we have our first one. That is derived from cos of x plus y. In the same way, and remember we are multiplying, we now will expand the second one. And that is following the same trend, cos x, cos y, and the minus will change to a plus, sine x, sine y. And to write that properly, we have a bracket because we are multiplying. Now what we are doing there is, you'll notice the terms. The first term in the first bracket is the same as the second term in the first term in the first bracket is the same as the first term in the second bracket. So what we're going to use is sum and difference. It's similar to if you have x minus y into x plus y. Then using FOIL, you'll get x squared to be your first term, and your last term would be minus y squared. You would not find inside and outside, as they would cancel off. So using the same principle, we're going to multiply our first terms. So cos x times cos x would give us cos squared x. Cos y times cos y is cos squared y. And a negative times a positive will give us a negative. So there's our first term, and our last term, sine x times sine x is sine squared x. And then sine y times sine y is sine y, sine squared y. Now, we're trying to get to the right-hand side. So you'll notice my second term has sine, and my first term has cos. Now, one of the formulas or identities to remember is that sine squared x plus cos squared x is equal to 1. And if we make cos squared the subject of the formula, we would get 1 minus sine squared x. Or we could make sine squared the subject of the formula, and that will give us 1 minus cos squared x. So we have an option. Now, since we're trying to prove the right-hand side, and if you look on the top, it only has sine in it, we're going to now change the cos squared to 1 minus sine squared. And we're also going to change the cos squared y to 1 minus sine squared y. And then bringing down our second term from the above, that's a sine squared x sine squared y. And then we're going to apply FOIL on the first two brackets, first, outer, inner, last. 1 times 1 is 1. And then our inside term is minus sine squared x. Our outside term is minus sine squared y. So we're going to say minus sine squared x minus sine squared y. And your last term will be a negative times a negative is a positive. Sine squared x times sine squared y would be sine squared x sine squared y. And just for understanding purposes, I'm just going to highlight this in red. We need to bring down that term, which is a minus sine squared x sine squared y. Now you'll notice that we have like term. Sine squared x sine squared y will cancel off with the last term. And that gives us 1 minus sine squared x minus sine squared y, which is actually equal to, if you look on the top, it's actually equal to the right hand side. Okay, we're looking at the second question, which now say hence. Hence basically means use the above. Determine the value of 1 minus sine squared 45 minus sine squared 15. Now if we compare that to the top, all that's taken place is x has been replaced with 45 and y has been replaced with 15. So they're actually giving us the x and the y value, which we're going to place into the left hand side to assist us. And if we do that, we're going to get cos of x plus y. Remember, x is now 45 plus y, which is now 15, times cos of x minus y, and remember x is 45 minus y, which is 15. And if we work this out, it's going to give us cos 45 plus 15 is 60 times cos 45 minus 15 is 30. Now, those are actually special angles, which we can find from our table, triangles, or we could use a calculator. Cos 60 is half, and cos 30 is actually root 3 over 2. And if we multiply the numerators, 1 times root 3 is root 3, and a root 2 times 2 in your denominators, giving you 4. Thank you.